This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. Alright, we're going to do a few more problems where we can find trig values using reference angles. But here's the important thing. If someone asks you to get the cosine of 2 pi over 3, there's more than one way to figure out that answer. So reference angles are one way to do it. Alright, so what do? We think about where that angle is. 2 pi over 3. Now I know that's 2/3 of the way to pi, right? Like you know, there's 1/3 of the way to the pi, 2/3 all the way to pi, right? If you think about that. If you need to change it to degrees, that's fine. If you change 2 pi over 3 to 2 pi over 3 to degrees, you could just substitute that 180 in for the pi, since that's exactly the same thing, and notice you would get 120 degrees. So it's up to you whether you want to think in terms of radians to draw where that is, or change it to degrees and then see where that is. All right, so how would we use the reference angle here? Well, what I do is I decide, if first of all, where that angle is in terms of which quadrant it's in. It's in quadrant 2. And in quadrant 2, I decide, is the cosine positive or negative? Remember, you can remember all students take calculus. So the sine is positive up here, right? They're all positive in the first quadrant, but in the second quadrant, only the sine is, which means the cosine is negative. So the cosine is negative, and so all we need to do is do the cosine of the reference angle. So I have to know what this angle is. You have to look at the terminal side, right? And I'm going to make an acute angle between that and the x-axis. Now, that's either 60 degrees or pi over 3. Up to you how you want to write that. I'm just going to write pi over 3 since the original was given, but of course that's the same thing as writing 60 degrees. So some people have already memorized what the cosine of pi over 3 is, or the cosine of 60, or maybe you draw a picture like me. I think, okay, 60 degrees is about like this. 1, 2 square roots of 3. And I just use the definitions of the right triangle trigonometry. So the cosine of 60 will be the adjacent over hypotenuse, which is 1/2. So my answer will have the minus sign. And then the cosine of pi over 3 is 1/2. And so there's your answer. Same thing whether I think of it as the cosine of pi over 3 or the cosine of 60. So that's how I would use my reference angle. Determine whether it's positive or negative, and then you take the cosine of the reference angle and write that answer here. Now the way I do this is I don't use reference angles. So just so you can see, there's a different way to do exactly the same problem. I start out the same. I draw the picture where it is, and it's over here. And then I just sort of make a little right triangle here. Okay, because I really am caring about this angle here. Okay, and I fill in the actual x and y values of the coordinate up here. So this would be -1, right? I could think of this as positive square roots of 3, and that's 2. So the cosine, I look at this picture and I write -1/2. So as you can see, I get the same answer. I just think about it differently. I'm still really looking at the reference angle because I'm paying attention to the fact that that's a 60-degree angle right there. All right, let's try another one. Feel free to put the video on pause and try this on your own. All right, so how are we going to do this? The sine of -255. So I'm going to draw a picture of where that is. -255. Well, 225, excuse me. All right, so that's 180, and then I got to go 45 degrees more. So there's my angle. And so here's my reference angle here, which is 45 degrees. So now I look at what quadrant this angle terminal side ends in, and it's in quadrant 2. And the sign is positive in quadrant 2. Again, if you want, you could use all students take calculus to remember that. I just think what the y value is, it's positive in quadrant 2. Sign goes along with the y value. And so it's going to be positive. So I know my answer is positive. You don't need to write a plus sign, but if you want, you can do that. Just to remind yourself that you did it. And then you just take the sign of the reference angle. The reference angle is right here at 45 degrees. And then either you've memorized that, or you could draw a picture of the 45, 45 triangle. It's 1 over square roots of 2, which, if you rationalize it, is square root of 2 over 2. So how do I do it? Start out exactly the same way. Draw my little picture. End up right here. Okay. Draw the triangle. And I just labeled the sides. This is -1 because I'm thinking of the actual x-coordinate of that point up there. And the y value would be 1 and 2. So this is still the 45, 45, 90 triangle, right? And now the sign is just the y value over this r. So it's 1 over square roots of 2. And when you rationalize that, you get square roots of 2 over 2. So you do get the same answer. So there's 2 ways to do the same problem. One person is just thinking in terms of reference angles, determining the sign, whether positive or negative, and then rewriting it using 45 degrees, looking at a triangle. I do it all at once. I just draw my triangle right in the x-axis and pay attention to the sign, in other words, S-I-G-N, when I figure out my answer here. All right, so that's all there really is to reference angles. What if you were asked whether two angles were, the sine of one angle is equal to, the sine of another angle, for instance. So let's try one more type of problem. So here's a question. Is the sine of 91 degrees equal to negative the sine of 89 degrees? Right. The idea here is to see if you could use reference angles to figure this out. All right. Because notice this 91 degrees is not acute. So how would you do this normally? How would you figure out what the sine of 91 degrees was using a reference angle? You'd say, well, where's 91 degrees? Well, it's just barely up here. I can't really draw it correctly, but let's just say that's 91 degrees. Then how many more would be here? Because I have to look at the angle it forms with the x-axis. That would be 89 degrees, right? So the reference angle for 91 degrees is 89 degrees. Okay? But then the question is, we have to determine the sine SIGN, whether it's positive or negative for this. The sine of 91 will be positive or negative. So here we've got all students take calculus. So the sine is positive in quadrant 2. So this answer is going to be positive, the sine of the reference angle. So I could see that that is not going to be true. It can't be negative, the sine. So now we could answer it. We didn't have to actually look anything up. No calculator, nothing. So the answer would be no. It would be true if it said the sine of 91 degrees was equal to the sine of 89 degrees. Because then I would have had the correct SIGN sign. Right, here's one more. Is the cosine of 13 pi over 12 equal to negative the cosine of pi over 12? So let's see, where is 13 pi over 12? Now 12 pi over 12 would be pi, so that would be going all the way to here, and you have to go an extra pi over 12 to get to 13 pi over 12. Now if you want, you could also change this to degrees if that's easier. So let's see, what angle does this form? Remember, you see what angle that forms between the terminal side of the angle and the x-axis? Well, if this is 12 pi over 12 and this is 13 pi over 12, that gives you a little extra pi over 12 here. Pi over 12. All right, so now, remember, all students take calculus right here. So we're going to figure out how we would find the cosine of 13 pi over 12 using that reference angle. So since that angle is in quadrant 3, will the cosine be positive or negative? And only the tangent is positive, right, of the 3 basic trig functions. So the cosine will be negative, and then we write the reference angle, which is pi over 12. Whoops. All right, and so I've got the cosine of 13 pi over 12 equals negative the cosine of pi over 12, which, that's exactly the question we had. We've just found out that's true. So the answer is a yes. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.